Hi everyone and welcome to STEM School. Now in today's video we'll be looking at scientific notation, or you might have seen it written as standard form. So I'm going to explain everything you need to know for this topic today, and then in part 2 video we'll go through some GCSE and Scottish National 5 exam questions so you guys can be better prepared. So what is scientific notation? We'll start off with that. Well, it's essentially a convenient method for writing out really large or really small numbers. So an example of a really large number would be the speed of light, which is something you would use quite often in physics calculations, okay? So the speed of light is 300 million meters per second. Okay, so most people will agree with me when I say that it's quite tedious having to write all this out, okay, because it's quite a large number. Even quite a small number like 0.000017, something like that, is quite tedious, right? So we want a way to write this more conveniently, okay? And the form that allows us to write this more conveniently will look something like this, okay? What it will look like is a times 10 to a power, okay? That's the magic form. And what we'll do is we'll break down each component of this, okay? So let's start off with this. Well, this will be a number between 1 and 10. 1 and 10. Okay, so this number can also be positive or negative. It can be a whole number or it can be a decimal number. Decimal, it depends on how precise you're going to make it, okay? Now let's move on to the power. So this could also be positive or negative. So if we have a positive power, right, we have a large number, okay, and I'll explain how that works, because what you're doing is, say if we had 10 to the power of 2, now using our rules of indices, we know that 10 to the power of 2 is equal to 100. So what you're doing is essentially having a number, you're timesing it by 100, okay, so that will make it a really large number. Now if we had 10 to the power of 3, now that would be 10 times 10 times 10, which is 1,000. So you're timesing any number, a times 1,000. So that'll make it a really large number. Now let's go to the other end of the spectrum. If we had a negative power, we would have a small number. Okay? Now let's do the same similar example. Let's do 10 to the power negative 2. Well, using our rules of indices for a negative power, we know we have to take the reciprocal, and it'll be a positive power in the denominator. So this will be 1 over 10 to the power of 2, which is equal to 1 over 100. So what you're doing is essentially dividing this number a by 100. You're making it smaller, and it'll be the same with 10 to the power of negative 3. You'll be doing 1 over 10 cubed, which is 1 over 10 times 10 times 10, which is 1 over 1,000. So a times 1 over 1,000, you're dividing it by 1,000, you're making it smaller, okay? Alright, so let's have a go at writing some large or small numbers into scientific notation form using this form that we have here, okay? So let's do the first example, and the first example is 92 million. So we're tasked with converting this to scientific notation. So first things first, we need a whole or decimal number between 1 and 10. So for this example, it'll be 9.2. It won't be 92, it'll be 9.2, okay? So now the second step is to ask ourselves, how many jumps does it take for the decimal point in 9.2 to move to the end of the number, okay? So the easiest way to visualize this is by literally drawing it out. So the point is here, decimal point is here, and we'll do 1 jump, 2 jumps, 3 jumps, 4, 5, 6, 7, okay? So the final answer will be 9.2 times 10 to the power of 7, okay? Positive number as it's a large number, and it takes 7 jumps for the decimal point to move to the end of the number. You have to appreciate that any whole number, 92 million, is written as 0.0 at the end. Now, let's do the second example. Let's do 305. 0, 0, 0. Okay, same as before, we need a whole or decimal number between 1 and 10. So for this, don't get confused by the 0 after the 3, okay? The decimal number will be 3.05. So we're doing 2 decimal point accuracy here. Now let's ask ourselves, how many jumps does it take for the decimal point to move to the end of the number? So 3, so it'll be here, 1 jump, 2 jumps, 3 jumps, 4, then 5. So the final answer will be 3.05 times 10 to the power of 5, okay? Now let's do some small numbers as well. Let's do 0.000456. So we need to convert this to standard form or scientific notation, okay? So we need a number between 1 and 10. So for this, it will be 4.56, okay? And then how many jumps does it take for this decimal point to move to the back here to this decimal point? Is the decimal point is not going to be after the 6, okay? So be careful with that. It will be starting here. So this will be 1 jump, 2 jumps, 3, 4. So the final answer will be 4.56 times 10 to the power of negative 4. We've got a negative power, and we've got the smaller number, okay? Now let's do one last example. Let's do 0.00007. Okay, so what's the number between 1 and 10 in this example? It will be 7.0. Okay, now how many jumps does it take to get back to the decimal point? So we have to be after the 7 where we start the jumps. Okay, so it will be 1 jump, 2 jumps, 3 jumps, 4, 5. 5 jumps for the decimal point, so the answer will be 7.0 times 10 to the power of negative 5. Okay, so you have to appreciate that any whole number is written as, so that will be 7.0. Just imagine the point afterwards. So what if you had a number that's in scientific notation and you wanted to reverse it back into the normal form? So I'll explain to you how to do that. So if you had 2.03 times 10 to the power of 6, okay, positive power, so we've got a really large number. So the first thing you have to do is write 203. We know it's going to be a large number, okay? So the 6 tells us how many times the decimal point jumps to get to the end of the number. So what you have to do is literally draw it out. From here, 2.03, 1 jump, 2 jump, 3 jumps, 4 jumps, 5, and 6. And now you just fill in the gaps. So it'll be a 0 here, 0 here, 0 here, and 0 here. And that's the final answer. Just write a 0 underneath all the loops. Okay, now let's do a smaller example. Let's do 8.7 times 10 to the power of negative 5. Negative power, so we've got a small number. So it'll be 0 point something. So what you do is you write 7, and then the 5 here tells you how many jumps the decimal point for an 8.7 moves back to the other decimal point here, okay? So what you have to do is start here, 8.7, do 1 jump, 2 jumps, 3 jumps, 4 jumps, and 5. And then fill in the gaps, 0, 0, 0, 0, then the point, and then it'll be 0. And that's the final answer. In the exam, you could be asked to do scientific notation calculations involving multiplying and dividing. So let's figure out how to do that. So firstly, multiplying. The method is to multiply the main numbers, which is the a in this form, and then add the powers. So let's do an example. Let's do 6 times 10 to the power of 7. What we're going to do is multiply that by 4 times 10 to the power of 2. So 2 numbers in scientific notation form. So what we're going to do is multiply the main numbers, which is the 6 times the 4. And then you're going to do times 10. And you're going to add the powers, just like the rules of indices rule. Okay? So what this will come down to is 24, 6 times 4, 24 times 10 to the power of 9. Now, as for scientific notation, you don't want to leave it in this form because the whole or decimal number is in between 1 and 10. We want it in this form. So what we're going to do is convert this. So it'll be 2.4. Now we have to modify the powers. So it'll be 2.4 times 10 to the power of 10. Okay? Now let's go on to dividing using scientific notation. The method for this is similar. What you have to do is divide the main numbers and then subtract the powers, which is very similar to the rules of indices rule. Okay? Now, the example that we're going to do is 4 times 10 to the power of 5, and we're going to divide it by 7 times 10 to the power of 2. So what we're going to do is divide their main numbers, and I'll just write it like this. 4 divided by 7, and then you're going to times 10, and then what we're going to do is subtract the powers. Okay, so it'll be 5 take away 2. So when you put 4 divided by 7 into a calculator, you'll get a long decimal, but let's just choose to do a 2 decimal point accuracy. So I'll do 0.57, and then we've got the times 10, and it'll be 5 take away 2 is 3. Now, this isn't the correct form because we want a whole or decimal number between 1 and 9, okay? So we have to convert this, just like we had to convert the previous question. So this will be 5.7. Now we have to convert the power, so it'll be 5.7 times 10 to the power of 2. And that's the final answer. And finally, we'll go over adding or subtracting using scientific notation. So the method is to write out the numbers in full, and then add or subtract them, and then finally convert the answer back to scientific notation, okay? It's just easier to convert from scientific notation first before we mess around with it. So we'll do an example. We'll do 4.4 times 10 to the power of 4. And what we're going to do is add it 5.31 times 10 to the power of 5. So first of all, what we need to do is convert the scientific notation form into full form as normal. So what you do here is you write the 4 and the 4. And then the power of 4 here tells us that it takes 4 jumps from this decimal point to get to the end of the number. So what you do is you literally draw it. It will be 1 jump, 2 jumps, 3 jumps, and 4 jumps. So then you fill it up with the zeros. Then let's do the same with this, okay? So you write 5, 3, 1, and the power of 5 means it takes 5 jumps for this decimal point to move to the end of the number. So the decimal point will be here. So you write 5 jumps, 1, 2, 3, 4, and 5, and fill it up with the zeros. And then what you can do is just simply do this and add it up. If it's in a non-calculator exam, you can't do it in your head. You just do it like this. So 0 plus 0, 0, 0, 0, 5, 7, 5. Okay? So the final answer isn't this, right? You want to put it back into scientific form. So the number here that's in between 1 and 10 for our form will be 5.75. And how many jumps does it take for the decimal point to move to the end of the number? Well, it will be 1 jump, 2 jumps, 3, 4, and 5. So it'll be 5.75 times 10 to the power of 5. Alright folks, that's everything for today. Check out my part 2 video as we do some GCSE and National 5 exam questions. As always, please do like and subscribe to make your revision easier and quicker, and I'll see you in the next video.